Good evening to all, and thanks for giving me this opportunity to pitch our technology on industrial production of Shikonin and its derivatives as food colorant. I hope I am audible, sir.
Yes, you are.
Okay, thank you so much. Next slide, please. Okay, so I'm talking about Shikonin derivatives. These are the, in broader sense, these are the naphthoquinone pigments mainly derived from the plants and also from some fungus. In Himalayan region, it is the Arnive euchroma, which is used to extract these molecules from the roots of this plant. However, there are plants like Lithospamum in Japan and China, and Alcana tinctoria in European countries, which is and all these plants of all roots of these plants, these contains these naphthoquinone derivatives, and these are mainly extracted from these plant sources. And there is, to our knowledge, there is no chemical synthesis at commercial level in all over the world. These metabolites, these pigments are being used in different industries like cosmetics, food, textiles, traditional medicine, phytopharmaceuticals, because these are traditionally used in Himalayan region, especially in Asian traditional system of medicine for lot of applications. And it can be used as a powder or extract into the products. The dominant Shikonin in these root powders is the deoxyshikonin, which is also there in our product. Next, please. The opportunities, yes, the global natural food colorant market is huge. It's over 2 billion in 2021, and it's growing at approximately 9.3% annual growth rate and expected to reach 4 billion by 2030. It's the main factors those are driving this industry is the increased demand for natural pigment, especially for food and personal care products, and these offers area of phytopharmaceutical properties like those mentioned here, and these can be have versatile applications like textile, printing, dye, hair dye, or many other products. The major global supplier of these natural colors are Hansen Holdings, Simrise, and FMC Corporation, the Color House, and Sensient Colors LLP, and Lycored USA. Next, please. Shikonin-based composition, what it call as Shikonin derivatives, are FSSAI-approved food colorant and phytopharmaceutical ingredient as well as nutraceutical ingredient. And these provides red coloring agents and can be used in vast wide products like food, cosmetics, dyes, and pharmaceuticals. The major production is from Lithospamum erythrorhizon and Arnivia euchroma in India and Nepal, China, and especially Lithospamum is known in Japanese. The price of these root powder is it depends upon the quality and quantity of these derivatives. It ranges from 3,000 per kg to root extract, which goes up 16,000 per kg. The major supplier of these Shikonin derivatives are mostly from China, including Yangling Biotech, Biological Engineering, Shanghai Jinta, and so on. Next, please. About our technology, because why we should prefer it, it's a sustainable system of production as we are targeting various sustainable goals. So yes, it is we are not dependent upon the natural resources, so we can produce these advantageous roots what we have induced under in vitro condition in the bioreactors, irrespective of geographical boundaries and environmental systems. It will ensure the year-round availability because these plants are generally available at high altitude above 3,500 above mean sea level altitude, and these are snowbound area. So it is seasonal availability there in from April to mostly October. But under in vitro condition, you can have a batch wise production. So you can have a batch per month. So I have a 12 batch in a year. As I have mentioned here, we have the shorter cultivation cycle because it's up to 5 weeks. Otherwise, in nature, it took around 3 to 4 years to produce some noticeable amount of these pigments. We have compared these products with our adventitious route, which we have induced under in vitro technologies, to compare with the market available wild source root powder as well as the plant from where we have induced these adventitious roots. So you can see that deoxyshikonin is the major compound. Shikonin is also there, but it's not quantifiable. Maybe there are a lot of reasons, maybe the temperature or drying conditions, and beta beta dimethyl shikonin. But as compared to wild, and we have the highest these pigment production in our case as compared to both wild source root powder procured from the market as well as the mother plant from where we have induced these root. One more thing, that we have not modified and done any genetic modification, which otherwise may be a concern for some person, because most of the people doesn't like these genetically modified products, especially for food and these personal care products. So it is a finally it's the sustainable technology which help in conservation of our natural resources and no dependency upon environment, because it also affects the stability of the these phytochemicals present in these extracts, and we can have a stable batch wise performance of these phytochemicals. Also, these lithospermum or nivea are both endangered, seasonal, and wildly grown. There is no captive cultivation for all these things. One more thing, that this is the first lithosperma is the first plant where plant cell and tissue culture technology has been developed to produce this phytochemical under in vitro condition. But somehow, because the cell line stability is the issue, so that's why we have gone for organ cultures, which are more stable than cell culture. Next, please. Next slide, please. So this is the overall technologies. You can see that from left hand side, first is the wild grown plants from where we have established the in vitro shoot cultures, and the leaves of these shoot cultures were used to induce these roots. And from roots, we have multiplied under in vitro condition these roots under different smell, and then produce in these suspension cultures. And then in bioreactors, you can see the color production inside these vessels, and these are the indigenized bioreactor, much cheaper than the what conventional bioreactor being used. Next, please. So who should be interested? Yes, the food pigment suppliers, the food and personal care processing industries, cosmetics, phytopharmaceuticals, and mostly the Shikonin suppliers. Next, please. So this technology is already the patent has been filed for these technologies, and we can produce these technologies at 5 liter. And now at present we are producing it in 10 liter bioreactors and working on 20 liter. Next, please. So we are looking for the partners who are interested in licensing this technology or hand-holding this for the scale up, as well as the raising third-party funds for collaborative projects. Next, please. So I had over 15-year experience of working on plant cell and tissue culture technologies, and we are producing a range of phytochemicals, including pecrosides, naphthoquinones, valproates from different high altitude medicinal plants, which are endangered to that area. And I had also experience on working on phytopharmaceutical formulation, nutraceutical formulation, and value addition of all these phytochemicals, especially in bioprocessing and bioreactor technologies. I am working for past 20 years. Next, please. Next, please. So IHBT is connected with the different industries, and we have over 50 entrepreneurs who are working on different area. You can see these the logos of different companies which are engaged with IHBT for different food and pharmaceutical products, cosmetics, and immunity boosting nutraceuticals and range of other products. And we are well connected with the industries as well as the MSME of the this government of India. With this, thank you so much.